Alright, time for another draftphysics.com, debatephysics.com video presentation. But it's just so futile. Anyway, alright, so just in honor of the occasion, yes, facepalm. So Ian Gosling has made a video, yes. 4 mass 1V and 1 mass 2V have equal quality of energy. Alright, so why did you do this 2 mass? You're supposed to have 4 mass at 1 velocity, sorry. So, yeah, so 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. Nonsense. Okay, so Despard already proved it. He already proved it's not true because obviously he did the experiment wrong, okay, and got that answer, got equality, okay. And so if he had done the experiment anywhere near right, it wouldn't have come close. It's just obvious. So this will be garbage. This will be another bullshit experiment contrived their special way to try to force it to come out their way, but there'll be some obvious stupid error, no doubt. He's got this stupid drawing still, in the video, so we know because the stupid drawing's there that the stupid argument's still there. Oh God, I hate this planet.
Hello, chaps.
Oh, fuck you. So let me make this the right size. I'll pause. Alright, so far you can't see enough to say, oh, what a pile of shit, but it's coming.
This is a rough demonstration.
Oh, fuck you. I mean, haven't we done this enough? Alright, we already know rough demonstration is bullshit. It's science. If you're going to make a claim, you got to make it with some sort of credibility. The experiment can't be an absolute pile of shit. It can be a shitty, but it can't be an absolute pile of shit.
To show that a 1 mass or 4 mass swung at 1.
So he says this is 1 height. We have no idea. He's pushed how far back he pushes it beyond this line. So he doesn't rest it on the surface and then pull the surface away. Right now, the sensible thing to do is put it on top of something and then pull it away, because the only time it's going to leave is when it goes over that last little edge. So you'll guarantee. So he can't learn anything from all these experiments. And he's crashing into a piece of foam, apparently. And he claims the foam is apparently, it obeys Hooke's law. He's proven it and demonstrated it. It's a valid scale. Now, he hasn't done any of this.
Velocity.
Oh, he's moving a piece of wood. He's using friction again. Now, didn't we already talk about friction? Oh, damn. So he's just redoing the same fucking stupid experiments where he claims friction's always the same. So it doesn't matter how fast you travel, okay, across ice, you'll always weigh the same and you'll always fall through the ice, okay, because friction is always the same. So will you, I mean, so just so lame. So why don't you just roll something? Why don't you just take a ball and roll it? Because it'll go 4 times as far, and you could just keep claiming that's 4 times the energy. Now, even though I've already asserted and clearly stated it's just going to be just like what Galileo said. It's going to be going half its velocity after it's traveled 3/4 of the distance. So quite obviously, the friction isn't linear. I mean, Galileo observed it fucking 400 years ago. And you're pulling this bullshit. 350, whatever.
It's got a similar energy.
So he's got foam and a piece of wood friction. And he says this is how you... This mechanism accurately measures how much energy something has. That's his assertion. So we're right back to the 1700s and Madame Chartelet and her denting clay with round objects. Okay, there's just no physics here, obviously. Obviously, physics doesn't fucking matter. It's just about nonsense. Because physics says these experiments have variables. And it's just a lie to say it doesn't matter what shape the object is that you're denting the clay with. It's just a lie to say it doesn't matter how pointy the arrow is, it goes just as far distanced into a substance. Obviously, it does matter how pointy it is. Okay, and obviously it does matter that measuring friction is the same as measuring friction on a surface. You're just measuring gravitational pressure. Okay, and obviously the pressure per inch at a high velocity is a lot less than the pressure per inch when you move very slowly. And that's just physics, that's facts, and all of these liars, these pieces of human garbage who defend this nonsense, all right, this isn't complicated physics. It isn't way above their understanding. They can perfectly understand the thin ice argument. They can perfectly understand that, yes, the friction's being created by the force of gravity is the thing pushing the surfaces together. If you did the experiment sideways, there wouldn't be any friction because nothing would be pushing the surfaces into each other. I mean, you people are just such pieces of garbage to defend this nonsense.
The same energy as a one mass with two velocity.
So we didn't see these measurements either. Ugh, ridiculous.
The weight here is just off the board, off of this baseboard. And then the first drop height, I've got two of these rings.
And again, so why not put the weight on the ring? Let it sit on the ring and then pull the ring away. Idiot. Moron.
This is the marks. 1, 2. Yeah, it's not perfect. It does twist a little bit.
Yeah, that's not the part that's really bad, okay? I mean, the twisting is always bad. Obviously, that uses energy in motion that's not going to give you your linear measurement, so it's not measuring that energy. And again, this is just the friction argument. Should I go to the trouble of drawing this again? You know, I can't believe people are this dishonest. All right, I'll do it. I have to go get a piece of paper. Alright, Peter to be back. Alright, so this was observed by Galileo, okay, in the early 1600s, okay, this falling thing, the idea is that if something doesn't fall in proportional amounts of distance, right, I mean, obviously, it's gaining acceleration. So something doesn't fall in like there's 1 unit of distance, 2 units of distance, 3 units of distance, 4 units of distance. No. What happens is there's this 1, 3, 5, 7, you know. And you can just understand it as the 1, 3 scenario, okay, in the sense that this amount of fall, okay, this one little tiny unit, that'll take 1 unit of time. And this whole thing will take 1 unit of time. Alright, so, and this is the same thing is true for rolling things or moving things where friction is being created by gravity. So he observed this on a ramp. And the thing is that something is going to be going half its speed, its final speed. Alright, it'll be going half that speed, alright, at this location rather than, so you take two of the same size masses, you give one velocity, give the other 2 velocity, alright, and you roll them, okay, you'll find that the one with 1 velocity only goes this distance, alright, and that will be exactly the same as this, 1 velocity. So you know what the 1 velocity experiment looks like. This is what it looks like. It's just this. Alright, you've seen it, so you know exactly what it is. So you don't even have to do the experiment to know for an absolute fact what 1 velocity looks like. One velocity looks like this little bit of distance. So you know that's exactly what you're going to get here. All right, and that this is the 1 unit of time, and this is 1 unit of time. And the fact is that this whole distance will be 1 unit of time, okay, and it'll be 3 units of distance. You'll be going half your speed here, okay? That's where you go half your speed. Here, 3/4 of the way down the track. So obviously the friction, okay, is weak in terms of taking your energy the faster you're going. And the slower you're going, the more energy you give to a surface. So it's basically, you know, if these lines represented how much energy you would lose into the ground, the slower you go, the more energy you lose. And the faster you're going, the less energy you lose per unit of distance. Per unit of time, it'll be exactly the same. Okay, so in the 1 unit of time here, you heated the ground the same amount as you did in this little unit of time. So in this short amount of distance, but same unit of time, you did just as much vibrating of the ground here that you did here. Alright, so I'm just saying that this is 400-year-old physics, you know, and 350-year-old physics. That understanding this concept of what contact is, and especially what contact is when gravity is the mechanism causing the contact, that these are real facts. So it's a real fact, okay, this going half the velocity, 3/4 of the distance. It's a real fact, and Ian Gosling hasn't said anything about that real fact, and instead just evades these real facts. And pretends that he is going to prove how much energy something has with a non-linear ruler. So he's just basically pulled out the bent ruler and say, look, I'm going to measure with this bent ruler. And he's going to call that science. He's defending science. Not silly dogmatic religion. No, he's defending science with basically an experiment that I've already asserted for 2 years is not linear. It's not a ruler. You can't do it that way. And he has no counter argument. He just says you will fall through thin ice. When no, you won't. And the only reason why you won't when you're going fast is because you applied less pressure to the ice. Facts. These are just facts.
So I've got 2 rings here, and then for double the velocity I've got 4 times that, or 4 2s are 8. Make sure my maths right. And I've got this little bit of foam here, very important. Without that foam...
there it bounces. Yeah.
The higher velocity mass is at a real disadvantage. Because
oh, that'll be interesting to hear. Yes, because it it weighs less than the wood. That's it. Yes, that's actually the truth. So yeah, it's a real problem. Oh God, he's so fucking stupid. Fast things can't give their velocity to things bigger than them. So if something hits something that weighs more than it weighs, it can't give it its velocity. It's not possible because momentum runs the universe. And the block of wood can't have more momentum.
The impulse force, if you like, is divided by the time of impulse. So something going much quicker, there's much more shock.
So all of this he's just making up. So the fact is that the wood can't go the velocity that the higher velocity object is going, and because it can't, because it would have too much momentum if it did, that's where these conversions have to happen. And whenever you have to convert velocities, if you're doing it without a lever, you're going to get bounces.
So with that bit of foam, it's giving the two velocity mass a fairer fight. It's allowing it to transfer its energy.
Look, putting a spring on doesn't change how much energy there is, so I don't really have a great deal of opposition to putting a spring on the block of wood, okay? Except that, again, you are going to get some kickback. But the fact that you're ignoring is that this ruler is not a ruler. It's a bent piece of crap. So, I mean, I'm just saying, Galileo would explain it to you, and you would just say what to Galileo? You fuck you, shut up, you don't know what you're talking about, you're a moron. If Galileo told you, don't you understand, it can't be a linear ruler if it's going half the speed after it's traveled 3/4 of the distance. If it's traveled 3/4 of the distance and that's when it's going half the velocity, it can't be a linear ruler. What would you say to Galileo if he explained that to you? Fuck.
Much more nicely, for want of a better word, without the loss due to shock. The quicker object is at a disadvantage because, because of that impulse, shock loss.
Says him again. So, or whatever.
It's roughly going to this second line. 4 mass,
is it?
1 velocity.
Is that what it roughly did? It looks short to me, but okay, sure. Oh yeah, that was definitely to the second line. Yeah, that was a ham. Yeah, no, really wasn't. Keep trying. Keep
I
trying.
wish I could stop it twisting.
You can. You just have to move the block of wood over. You see which way it twists, then you say, oh, that must be because it's hitting the wood where there's more wood on one side than the other. So if I hit it in the middle, I'll get a straighter motion. That was a little better. There, that was pretty straight. That was pretty good.
With repeating it, might be boring, but we're getting an indication.
Yes, we're getting an indication. That's right. But what's the point? It's not a linear ruler.
There. Now, let's do 2 masses.
Well, I thought that was 2 masses. So, I don't know what I missed, but whatever. So now they're not connected to each other. So he just did a big solid thing. See, I don't get what he's doing here. I don't know what 2 masses means. This looks like it's going to be the 1 mass. So he has a big solid thing, and then he's got a bunch of washers for the other one. Again, you know, just such bullshit. They're going to hit unevenly. They have friction with each other, moving side to side. Lots of places. You know, not a good experiment. To his own disadvantage, frankly. I didn't know the video was going to be full of this, so we'll pause. Alright, so he says he's got 2 loops on the string to compensate for something. Now, apparently this is the 1 mass. I don't know why there's 3 washers, but whatever.
For the stretch, obviously with the 4 mass, it stretches the string right up. So it's just above the baseboard again.
So he's saying the center of the mass of the two is not the same place. So that's not good.
Two masses at one velocity.
So I don't know what two masses is. So he's saying this is, he did a 4 mass and now this is a 2 mass. And then he's going to do the 1 mass at twice the velocity. Is that the idea? Way short there, unfortunately. Presumably it's supposed to go to the first line. But because the washers aren't stuck to each other.
Second line.
Yeah, it doesn't make it.
I've got a few things against me. I've got a bit of the weight missing on this one.
Oh, yeah, great.
So it's a little bit less than what it should be.
And they're moving.
But again, this is a rough indication.
It's pretty. It's very rough. It's so rough, it's useless.
What Gary says.
Look, I'm sorry. What momentum as an argument says is that you have to conserve the momentum, and that all you've done is double the momentum by doubling the mass. They have the same velocity. You doubled the mass. Even the kinetic energy theory says you've doubled the mass. You know, in one experiment, this is half the mass. So you have the mass, so you have the energy. Kinetic energy says the same thing. Because the part you're squaring is the same number. It's the same mass. The same velocity, and you change the mass. So kinetic energy says there should be half the kinetic energy also. So fuck you, asshole.
Is that the 1 mass at 1 velocity, or I should say the 4 mass at 1 velocity, is twice the energy of a 1 mass at 2 velocity.
Oh, Jesus. No, a 2 mass at 1 velocity. Oh, brother. You just did a 1, you did a half the mass, you did a whatever. If it was 1 to 2, it's 4 and 2. So you did half the mass at the same velocity. Oh, stupid fuck. So I don't know what this one's going to be. Why is he restringing it? This is a 1 mass now? I don't know. So 1 mass, a 2 mass is 3 washers and a 1 mass is 2 washers? I don't think that's likely to be true.
But what science says is that...
So again, there's no scientist saying it. So link me to your video where a scientist is saying the shit you're saying. Go ahead, link me to the video where the scientist says this happens. They don't have the guts to say it, okay? So don't say that science says because they don't have the guts to say it. Physicists don't say 8-pound bowling balls going twice as fast knock down twice as many pins. They're afraid to say it because they know it's silly. They don't say it takes 25 times the fuel to go 5 times as fast because they know if they say it, it's going to sound stupid and idiotic. So they don't even say it, shithead. They're too much of a coward to say it. Because they know they can't defend it.
They're the same. Because of kinetic energy, of course.
So who knows what the fuck this is.
And I thought of many ways of trying to measure this energy. And the elastic band idea is a good one.
Except you didn't prove that obeys Hooke's law either. So why don't you go with put a nail on it and let the nail penetrate a piece of clay. You know, go all the way in. Not dent the clay, penetrate the clay. That's a good one. Why haven't you tried that one?
Regardless of whether it follows Hooke's law.
So there's no regardless. It either does or it doesn't. Again, if the scale doesn't follow Hooke's law, all these numbers don't mean anything. You can't understand that? That the only way this scale can be used to measure anything is because it's relying on Hooke's law. Oh, God damn.
Or doesn't follow Hooke's law closely. Because all we want to show is that they're the same. That
no, I'm sorry. It's just imbecilic to say I don't need a ruler that has standard notches on it. All I need to do is the experiment where I make 2 notches on the ruler, and then I say, well, because one is twice as much as the other, then that's got to be the obvious answer. And obviously with the block of wood, as I just pointed out, it's going half the velocity 3/4 of the way down the track. So why don't you, until you can explain how it's going half the velocity 3/4 of the way down the track, and how you can make some kind of credible argument that it lost 3/4 of its energy and now only has 1/2 of its velocity. Oh, too stupid. When the obvious answer is the thin ice argument. The reason why you don't fall through the ice when you go fast across it is because you did in fact give the ice less energy. That's what in fact happened.
4 mass at 1 velocity is the same energy as 1 mass at 2 velocity.
Alright, so they've had 300 years to prove that axiom of Leibniz's, and they haven't come close. There's just no physical evidence that this nonsense statement, 4 pounds dropped 1 foot, is the same energy as 1 pound dropped 4 feet. No physical evidence. And as I pointed out, Despard did the experiment, and he did it really badly. That is, he put the 3 mass in the wrong location, the added 3 mass, and basically proved that they can't be equal because he made them equal doing the experiment wrong. So they can't possibly, when you do the experiment right, they couldn't have possibly been equal.
So therefore we're looking for the same deflection. So as long as they were the same, that was all we were interested in.
But again, it's pointless to say as long as they are the same, that's all we're interested in, if the factor of velocity changes how the ruler measures. So if the ruler measures different based on how fast something's moving, you've defeated your own argument. So again, we really are back to the 1700s and denting clay. Same argument there, okay, that you have to understand the round surface isn't linear. And if both objects don't penetrate the clay the same distance, there's a bias against the one that penetrates less distance.
Actually, regardless of Hooke's law.
So regardless of the bias, he's just saying, who cares about biases? We don't care that the system is biased against. It's just like we don't care if it's a grotesque cheat. I mean, it's just... I almost wanted to make a comparison to the people who are like saying some guy could grow up male, okay, and because he gets a sex change operation, all of a sudden he is a real girl, okay, and even though he's 6'5", okay, and has, arms twice as long as all the other women, it's okay if he beats them, in the Olympics. No, it's not really okay. It's fucking stupid. But anyway. Alright, so, before he said something about, I've been trying to figure out ways to do this. And yeah, we all should figure that out. But I mentioned before hydraulics. Because, there's very little loss. It's a pretty functional system. And you should be able to move the same amount of fluid, blah, blah, blah. Cylinder size, all that kind of stuff. So, a half the size piston moving at twice the velocity is going to displace the same volume, as a full-size cylinder moving 1 velocity. And so those kind of rules are consistent. But again, we're back to levers. Levers are a way to do this experiment. Okay, it'll fail on the lever right away. You can't balance on a balance. Okay, you can't balance 4 pounds at 1 distance and 1 pound at 4 distances. You can't do it. And the fact that you can't do it proves, okay, that they aren't equalities. I mean, should anybody have to say any more than that? Okay, that the fact is the lever proves it. Solves it for us. One mass at 2 velocity would be 2 notches on the lever. 4 mass, 1 notch. That won't balance. One mass 4 will balance, but that's 4 times the velocity. Okay, so but I did that one on my porch. So we already know 4 times the velocity. The 1 mass at 4 times the velocity equals a 4 mass at 1 velocity. Okay. So, I mean, how do you explain that, Ian? I mean, a balance proves the two things aren't equal.
We're showing a similarity of outcome. Because Gary says that one should be twice as much as the other one, according to him.
Yes, according to momentum as a theory of energy. So according to Newton also. Probably Descartes and probably Galileo. I think Galileo certainly, you know, he did so many experiments. Come on. You don't think Galileo knows the right answer to this one?
Science says no, it's equal. So
and they say it, right? They don't demonstrate it with any experimental evidence. So there's 0 experimental evidence. You can't link to a single goddamn video on this subject. So in all these years of science history, there's not a documented experiment demonstrating what he claims to be the truth. And the only experiment we have is this silly washers banged into a piece of wood with a hunk of foam on it. Yeah, that's the great experiment. Oh, fuck. No, well, we have Brozo's lever.
Have a look there. Here's a 1 mass at 2 velocity.
So again, proves absolutely nothing. Okay, in terms of proving how much energy the thing has, because again we're right back to the fact that he could have just rolled something and twice the velocity is going to roll twice as far. I mean 4 times as far. Just a fact. And it's not going to do it because it has 4 times the energy. It's going to do it in twice the time. Okay, only twice the time. It'll only take it twice the time to go 4 times the distance. It was only getting hit by gravity for twice the time. It's only twice the friction. It didn't create 4 times the friction.
It's immediately clear we're getting much further than this halfway line where the 2 mass at 1 velocity was going. Which according to him, I suppose, this should be doing. But no, it's equivalent.
No, it obviously, again, let's just understand, the flaw in this experiment is that this piece of wood is sensitive to velocity. It behaves differently depending on the velocity it's hit with. It will go further with the higher the velocity, the more distance it travels, because it actually endures less friction. And if you could do it in slow motion, some way to capture the idea that it's going to do these distances in different amounts of time, and that the wood itself is going to move exactly as Galileo states. That is, it's going to initially go fast, and then it's going to go slow, and it's going to do the 3, 1, 3, 5, 7 thing.
To the 4 mass at 1 velocity, as predicted.
So predicted by who again? Okay, and again acknowledging what? That this is the proper way to measure how much energy something has. So you haven't proven anything. So this is the ballistic pendulum all over again, right? So the ballistic pendulum loses 99.94% of the kinetic energy. And they say, well, it's in heat and deformation, even though you only lost 3% of the momentum. So somehow 3% of the momentum equals 99.94% of the kinetic energy. So you did a whole bunch of work without using any momentum. Ridiculous. I mean, this is so fucking stupid.
Anyway.
Steaming piece of shit experiment. Already been argued for 2 years on almost a weekly basis why this experiment is a pile of shit. And you haven't countered the argument in any way that basically, again, the fact that the thing rolling 4 times as fast is going half its velocity after traveling 3/4 of the distance. That fact is glaring and decisive in understanding that it can't possibly have anything to do with anything called energy measurement.
For what it's worth, and just to finish, whilst you're in a good mood, Gary, you say that...
Fuck you in the ass till dead, okay? You lied about your first video. Your first video, when you drew this, you made this absurd claim that if you shot these objects straight across, that somehow they're going to fall exactly the same distance, okay? That this one would go 4 times, twice the velocity would go 4 times the distance. It's absolutely wrong. It's been proven. This one, hundreds of experiments on the internet show that this is not true, what you claim to be true. Your video was a piece of shit. Okay. And you're proud of that lie. Because it's a lie now, because he's claiming that even, in the comment section you can see, well, maybe I got that wrong. But he didn't annotate anything, he hasn't conceded, and now he's made a follow-up video asserting that it was absolutely the truth. And he's going to defend it as the truth when it's an absolute pile of shit nonsense. You're just lying to people. And you're proud of it.
Off of this ramp, although it's 4 times the distance at twice velocity here...
It doesn't happen. It doesn't go 4 times the distance. It's a lie.
If we allowed them to fall, that somehow it would come back as 2 to 1.
It wouldn't somehow do it. It would do it by the laws of physics, idiot. This motion, the velocity in this direction, doesn't change. Okay, we're saying air resistance is minimal. So if we're conceding that this velocity doesn't change, they all follow a parabola. Alright, so you can distort it by shooting the objects up. But it'll be just a short-term distortion. The amount of up will be eliminated by every unit of down. So if you say, okay, I shot it 30 feet up. Well, if you let it fall an extra 30 feet down, well, you've already lost half of the change, the distortion you made. And if you let them drop 60, then you're down to 1/3. And you let them drop 90, you're down to 20%. So you'll minimize how much you can distort the outcome. Okay, and so if you let them go a couple 100 feet, the amount of distance, this 30 feet won't matter anymore. It'll be irrelevant. Your distortion won't have any effect on the outcome. And it will be 2 to 1, revealing that twice the speed gets you twice the distance. Ja!
I think you ought to apologise yourself for misleading your viewers.
Didn't happen.
However far it fell, whether it was miles off the Earth's surface or 100 feet or whatever, it would still be 4.
Not if you shoot it up in the air, you shithead. I mean, I'll draw this, but I mean, he's so dishonest. He's such a liar. He's so fucking stupid. All right, he doesn't even understand his own video, his own argument. I mean, he's such a fucking moron. A lying, dishonest, fibbing, cheating, scummy piece of absolute human garbage. evil. He is evil. An evil fanatic. Religious fanatic. Alright, so the simple experiment was you shoot them this way. Alright, and they'll fall at an arc. Okay, and twice the velocity will go twice the distance. Okay, not complicated. Twice the velocity, twice the distance, because they fall at exactly the same rate. So in that same amount of time, obviously something twice as fast where you're not removing its velocity, you're not taking it with friction, it will just continue to go twice the velocity. And so you'll end up with that. Okay, 1 unit of distance, 2 units of distance, right? It's going 100 miles an hour. It goes twice as far as something going 50 miles an hour. Now, if you shoot them up in the gravity, okay, and that means you're going to get this. You're going to change the parabola, okay? But the fact is that they're both, it's still a parabola. So the higher velocity one, okay, will still, okay, go twice as far. It's just that it has a different parabola over the distance. So this distance will still be 2 to 1 over time. But this distance has to be substantially more, okay, the falling distance, than the shooting up distance. So obviously you could shoot something straight up and straight down. It doesn't go any velocity in this direction. So you're saying that the two objects have to go the same falling distance, and obviously the higher velocity one will go a higher distance up in the air. Okay, so that means it will fall for a longer period of time if they land on the same surface here. But if they land on a surface way down here, the amount of time is going to be almost the same, because this time will be very large, this time will be very small. Okay, so the distortion will be minimal. That's how it works, fuckhead. That's physics, you lying sack of shit. Absolute fact, physics.
4 times the distance of this one. The trajectory is not going to change if it's...
Yes, it will. So it's just a fact that they're always going this way. And the amount of, over the longer the period the time goes, now the arc of their motion, you know, what angle they're traveling at changes. Okay, because the distance down becomes much larger than the distance this way, so the angle changes, but it's still going that way at a velocity. It's just the velocity going this way is getting higher and higher because of gravity, because you're allowing it to free fall. So a huge percentage of its energy becomes energy down, and a small amount of its energy is energy in a direction.
4 times the distance here at whatever this height is. You times this height by 10, it's still going to be 4 times the distance when they land.
Okay, so he just said it again as if that happens. It is not 4. You're such a fucking goddamn lying sack of shit. Oh, you've already been proven. It's already proven in 100 experiments, thousands of experiments. Okay, that what you said is absolutely wrong. It doesn't happen. So if you launch them straight, okay, it doesn't go 4 times as far. That's just a fucking lie. It's not the truth. If you multiply that by 10, yeah, it still doesn't happen, jackass. It doesn't go 4 times the distance. So again, your little hook, this little fucking bullshit hook he put here, he didn't talk about it at all. So this is he's such a fucking liar. I mean, right here, he talks in the second video about, well, what if I shoot them up in the air? Yes, that will change the experiment, okay? So if you shoot them up in the air and you limit how far they can fall, that is, they can't fall any more than a small percentage of that distance, then the higher velocity one will go 4 times as far. But it won't happen, it absolutely won't happen, if you allow the falling distance to be greater than the launching distance. And the greater the falling distance is, the closer and closer you'll get to 2 to 1 in terms of distance. You lying piece of fucking shit.
for misleading people there yourself.
Didn't happen. Didn't happen, liar. God, he's just such a piece of scum. What the fuck happened to my arrow? He said, now it's going to bother me. I didn't turn it off. Where's the arrow? Where the fuck is it? Somehow got off the screen. So I have to go find it. How come it doesn't show up? That really is irritating. I can't select it. That's it. That's not the arrow. I don't know. I don't understand that. Alright, never mind. I'll pause. Well, that's going to irritate me. I can't find it. Anyway.
Thanks for watching. See you later.
What a pathetic liar. Alright, anyway, just terrible. Just awful, awful, awful video. Alright, such bad physics, bad science, just so deceptive, so dishonest. I mean, that end bit with, you know, again, asserting something that just absolutely isn't true. You know, and then defending it. Amazing. I just, you know, I'm just surprised people are willing to be that corrupt and dishonest right in front of everyone. You know, it's disgusting. Humans suck.